Hey everybody! On this video we're going to expand on the video I made called Domain of a Rational Function Excluded Values, and we're going to talk about how that applies to interval notation. So for this problem we got x cannot equal plus or minus 7. Now remember, we did that by setting the denominator not equal to 0 and solving. Okay, but what does this mean as far as interval notation? Well, interval notation, always think of, first we're going to consider all of infinity, and then we're going to look at what it can't be. So could it be negative infinity? Yes. Then we can go all the way up to negative 7. Now, from negative 7, we can't have negative 7. We're going to do a soft parenthesis. If you can't have it, you do a soft parenthesis. And we're going to stick that together with a union sign. And then we're going to continue from negative 7. Now, why do we have to break it up like this? So that we know we have the soft parentheses, so we're not including negative 7. Then I can go all the way, I could do 1, 0, whatever, all the way up to 7, and then I can't do 7 because I said x cannot equal 7. And then we're going to go similarly 7 all the way to infinity. Alright, so that's interval notation for the first one. And for the second one, for g of x, we got x cannot equal a positive 5. So what does that mean? Well, I can go from negative infinity all the way to 5. Any of those numbers are fine, but then 5 is not fine. So now I'm going to go from 5 to infinity. And make sure you include that union, because that's where the break is right at 5. So that is interval notation when you're talking about domain of a rational function.